So today we're going to continue our lesson on polynomials, and we're going to talk about like terms. Like terms in algebra have the same variable raised to the same exponents. So they are the same variable raised to the same degree. For example, x, 5x, and minus 2x are like terms. They all have the variable x to the power of 1. 13y squared minus 8y squared and y squared are all considered like. They all have the variable y raised to the exponent 2. In other words, they're the same variable raised to the same degree. And you may be wondering, why is this important? Well, because if you ever have like terms, you can combine like terms. Let's look at this example right here. 3d plus 5d plus 12d. We can combine these like terms by simply adding the coefficients. So 3 plus 5 is 8, plus 12 is 20. So if I have 3d's, 5d's, and 12d's, 3 plus 5 plus 12 is 20. So I have 20d's. Now I was only able to add them because they were like. They were the same variable raised to the same exponent. Let's move on to the next example. B. Combine like terms. I have the same variable. Check. And these variables are all raised to the same degrees, to the same exponent. So I simply add the coefficients. So I take a look at the coefficients. My coefficients here are positive 7, minus 1, plus 4. So 7 minus 1 plus 4, so 7 minus 1 is 6, plus 4 is 10. So I have 10k cubed. Or in fact, you can say, well, I have 7k cubes, and I take away 1k cubed, so that leaves me with 6k cubes. And then if I have 6k cubes and I add 4k cubes, that leaves me with 10k cubed. All right. Unlike terms. So unlike terms is really important that you're able to differentiate what terms are like and what terms are unlike. Unlike terms in algebra have different variables, or they may have the same variable but different exponents or degrees. So for instance, if we take a look at our first example here, 6w plus 2h are unlike. What makes them unlike is that we are talking different variables, w and h. If we take a look at this next example, 5x plus 3x squared, well, we have the same variable. However, it is important to note that the variable in front of, or the variable in terms of 5x has the exponent 1. So in fact, we have the same variable, but the degrees are different. So you cannot add them. They are unlike. So as we continue here, we're going to combine like terms. I always think it's a really good algebraic practice to move all like terms beside each other. It really communicates your ideas well. So I'm going to pick out my like terms. 3m and 5m are like. 4n and 6n are also like. But the m's are like m's, the n's are like m's. So I'm just going to reorganize my thoughts, and I'm going to say 3m plus 5m and I'm going to switch colors, plus 4n plus 6n, and now I'm able to do the math. I'm in a much better position. 3m plus 5m is 8m. I've combined these two terms, plus 4n plus 6n is 10n. So when I combine my like terms in this example, I can simplify. We call this simplifying when we combine like terms. The above expression now can be written as 8m plus 10n. Fair enough. Moving on to the next example. I always like to underline my like terms, especially when I get started. So I'm going to underline terms that are like. I ask myself, is there anything that's like 2y squared? And in fact, it's 6y squared. Same variable, same exponent. Next, minus y minus 4y. I ask myself, are these like? And indeed they are, because they have the same variable, y, raised to the exponent, and the exponents for these ones are 1 and 1. But convention says we don't write those down. So I'm just going to stick my like terms together. So 2y squared plus 6y, 6y squared. Make sure I have written down those. Those were my blue terms, or my y squared terms. Minus y minus 4y. Now it's really important when I'm taking a look, I know that when I combine y squares together, my variable along with my degree will be y squared. 2y squared plus 6y squared is going to yield 8y squared. Minus y minus 4y, well, remember that this is really minus 1y. Minus 1y minus 4y is going to be minus 5y. And there we have it. All right. Maybe I can pick up the pace a bit, right, and not be so verbose. So I'm going to collect like terms. I'm going to underline everything that's like. Next thing I'm just going to simply write those like terms beside each other. And then I'm going to carry out my mathematical operation where it is 14k plus 7 minus 5 is going to be plus 2. So it's 14k plus 2. Last but not least, I'm going to stop the video and then I'm going to offer a separate video discussion of this.